Hello class, welcome to our lesson today. We're going to be looking at functions again. We're going to talk about a few aspects of functions to add into our repertoire of things we need to understand. Remember what we talked about in our previous lesson was that a function has to have for every input only one output. In a graph, it must pass the vertical line test. And then when we graphed linear equations and linear functions, we plugged in values for x and then substituted them and got an answer for y. Let's go ahead and get started with our first topic, which is dealing with trying to figure out what the function rule is from the inputs to the outputs. Now, you're going to be doing a lot of these ideas when you get to your algebra classes, and there's different strategies in order to figure them out. Most of the questions you're looking at right now will have some relationship between the inputs and outputs, and your goal is to figure out that relationship. So if you go from left to right, you say, well, how do I get from 2 to 8? Well, you could say it's plus 6, or you could say it's times 4. If you use the other numbers to help you, so if I get from 3 to 12, whatever the rule is, it has to be the same for every input to output. Okay, so you can't say, oh, this one's plus 6, and this one's plus 9, this one's plus whatever, okay, and keep going down the list. It has to be consistent. So every input is times 4 to the output. So then my function rule is the output, which is y, equals 4 times the input, which is x. This is the function rule for this table in this situation. The next question, I just look at the x and y's. Notice they're going down, so it's probably involving some type of negative. And in fact, in this case, all of the inputs are being subtracted by 9 to get to my outputs. So then my output, y equals, and then it's the input minus 9. Again, the goal here is that you're just looking at and saying, well, what's the relationship between them? And then you make sure that it works for each row going down the list. The next topic we need to talk about are what are known as intercepts. So there are two main intercepts that you want to understand. First is what's called the x-intercept, which is where a graph crosses the x-axis. Notice here that every point on the x-axis will go left or right, but not up or down at all. So the y value for that will be 0. So for example, this point right here, this is an x-intercept, and it's the point 3, 0, because it's 3 to the right and up 0 points from the x-axis. A y-intercept is just the opposite. It's going to have an x value of 0, and it's going to be on the y-axis, because I don't move left or right, but I do move up or down. So what you want to make sure you understand is that intercepts, x and y intercepts, are ordered pairs. There are times where you might see them written a little bit different than maybe what I'm showing right here, but remember that they are ordered pairs, and the x-intercepts have a y value of 0, like this one right here, and the y-intercepts have an x value of 0, like this one right here. So for this graph, it says find the slope and the intercepts. I started first by finding the intercepts. So the x-intercept is where it crosses the x-axis. So that's this point right here, which is the point 2, 0, because it's to the right 2 and up 0. The y-intercept is down here at negative 5. The slope then could be found by using these 2 points. So from here, I go up 5 over 2, and that would be the slope of 5 over 2. You could also do the slope formula, y2 minus y1 over x2 minus x1. That will give you the same answer, but this might be just as easy to find in terms of figuring out the slope. The next question has the same idea, so find the x-intercept. So the x-intercept is here at negative 3, 0. The y-intercept is down 1, so that would be down 1, so that would be 0, negative 1. And then the slope is negative 1/3, because from here, from left to right, from the negative 3, 0, I'll go down 1 and then over to the right 3. So down 1 to the right 3. And that would be a slope of negative 1/3 because I'm going in the downward direction from left to right. That's a good indicator if you're on the right track. The other way that you could look at this compared to the last one, this one had a slope of 5 over 2, which is 2.5. Notice how much steeper this one is compared to the 1/3 of this graph. Even though it's negative, it's a very shallow slope because it's only going down 1 for every 3 across. The next question is kind of the odd situation that only has one x and y intercept because it's the origin. Okay, so 0, 0 is both the x and y intercept for this graph. To find the slope, then, you got to find a second point that you can use. I picked this point right here, 2, 3, because it works out well on the graph. So that would mean the slope is up 3 over 2, because remember, it's always change in y over change in x. You could still do the y2 minus y1 approach, but you have to use another point on the graph, not one of the intercepts, because you need 2 points in order to figure out what the slope is for a line. The next 2 questions we talked about a little bit in our previous lesson, but I want to make sure we reiterate a few things. This question is a horizontal line, so the first thing to see is that there's no x-intercept because this graph is never going to cross the x-axis. The y-intercept is 0, 3 because it's up 3. And then the slope is 0 because I'm not rising at all, so it's a rise of 0, and I don't care what the denominator is for the run. It could be 0 over 10, it could be 0 over negative 3. It doesn't matter that piece because 0 divided by a number like that will be still 0. So remember, horizontal lines have a slope of 0 because there's no rise in the graph, and you can run as far as you want to the left or right. The next graph is kind of the opposite idea. So it has an x-intercept of negative 3, 0 because it's to the left 3. It has no y-intercept because this graph is never going to cross the y-axis. Now this slope is a little bit different because it's going to have a 0 on the bottom. You can rise as far up or down as you want. So you could say, oh, I'm going to rise 10, but then I'm not moving to the left or right at all. So it's just a rise of 10 and a run of nothing. So that would mean you have 10 over nothing or 3 over nothing or negative 7 over nothing. Whatever it is, it's over 0 now. And you can't divide by 0. That's not allowed in mathematics. So because I can't divide by 0, we consider this to be an undefined slope. So if a line is perfectly vertical, it's an undefined slope, which also should correlate to the fact that it fails the vertical line test. The only linear graph that fails the vertical line test is a vertical line, which means this is not a function because there's more than one output for the same input of negative 3 in this case. So realize vertical lines have undefined slope because you can't divide by 0. Horizontal lines have a slope of 0 because it's 0 on the numerator, not the denominator. Today your homework is a function worksheet. It's day 2. The first group of the worksheet for the packet today is the same as yesterday. So it's plug in an input, substitute, plug in and find the output, then connect the dots and draw the graph. I wanted to do that again because I think honestly that's one of the major building blocks we need to make sure that are okay. Make sure you understand how to deal with intercepts. Make sure you understand how to find slope. But you're needing to plug in at least one negative, 0, and one positive into your inputs, show the substitution, and then your outputs. The last page has some relationships between two different units. So for example, number 11 on the last page says X pints to Y cups. So here's what I would do first. Each graph like this is going to be 0, 0 to start with because if you have nothing, you still have nothing in cups or pints. So one of the points that you probably want to graph is 0, 0. From there, I would say, okay, if it's X, so 1 pint, there's 2 pints in a cup, so 1 pint is 2 cups. So 1 pint, 2 cups, and then I graph the point over 1 up 2. 2 pints, 4 cups, over 2 up 4. And then keep going that route, and you should get a line. Now this graph probably doesn't go downward, it just stops at 0, 0, kind of like our proportional relationships did that we did earlier in the semester. And the reason for that is you can't really have negative of something like this. So you can start at 0, 0, and then you notice your graph just goes kind of upward in the top right of each graph. And then the relationship is just whatever the unit conversion is between them. So 4 pints is 8 cups, and then it kind of goes from there. If you had to find the slope, you could do that by doing rise over run or changing y over changing x from the table. There's lots of options there to look at that. Again, please make sure you understand how to deal with intercepts, how to deal with slope, especially 0 and undefined slope, and then we'll use that information to help with things with linear functions in the future. Have a good day, everyone.